Okay, so the time now is 5:04 p.m. Today is 28 March. Yesterday I skipped my my daily line 75 grind because I was too tired. So today we're going to be looking at one dynamic medium level dynamic programming question. So uh, the question will be decode ways. Okay, so I've actually solved the problem beforehand, and it took quite a while to understand what was going on. But basically, in general, ET has two solutions. You either go top down or you go bottom up. Yeah. So this is a top down approach. So you start from the basically top down just means you start from the left. Yeah. So if you look at the algorithm, the top down approach, right? You are so-called trying to not say start from the left, you are trying to see how many ways you can go about pairing this and then this together just to get a solution. And then you combine the solution upwards. Yeah. So this is the same logic as the recursive approach, but with memoization. So there's another alternative method known as the bottom-up method. So this is iterative. So starting at index I, how many ways? So I is the number of ways to decode the string from uh, I all the way to the end of the, this basically just denotes starting from index, let's say 2 or 3 all the way to the end. And the answer we want is DP0. Yeah. So what this does is it goes from all the way to the right. It starts at the last number. So let's say 2. And then it will check if the number is 0, you don't care. If not, dpi is equals to dpi plus 1. Okay, so what this means is that uh, if let's say at this index, right, it's not 0, then we will say that at index 3, it is equals to index 4, right? Which is, so by default, if your dps dot length, right, which is index 4 in this case, which is so-called out of bounds, you have one way, because the fact that you can reach here means that so if let's say your string is 1012, right, or maybe if your string is just 12, right, so the fact that you can recurse all the way until the end of the string shows that there is one way to do it, to arrange this. So by default, s dot length gives you one way. Okay, so from index 4, there is one way to decode the string. So this dp3 will be equals to dp4, which means that index 3, sorry, index 3 is lower, number 2. You have one way to do it, which is correct, because for 2, there's only one way to decode it, which is just to e. Then if I plus 1, which is 4, is less than s dot length, so this doesn't apply, because it's already at the end of the string, we ignore that. Okay, then we go to the next one, we minus, and then we go to index 1, index 2, which is number 1. So again, this is not equals to 0. Yeah, so dpi is equals to dpi plus 1, which is 1, plus the array and position index 2 is equals to index 3, which is previously 1, right? So as if let's say the character is, so we have to look at this if statement. So I plus 1 is less than string dot length. Because string dot length is 4, I plus 1 is 3. So we have to check, is 12 a valid number way to interpret? So if 12 is a valid way to interpret, we have to consider this, and then we add it. So we add the string afterwards, which is 1. So it does make sense, because 2, there's one way to interpret 2. Okay? And when you add 1 to it, it becomes 2 ways to interpret 12. Right? You can either have 1 and 2 or 12. Yeah. So this method is more of trying to say that if it starts with 0, right, you don't do anything to it, because anything that starts with 0 is not valid. If it starts with 1, there is a chance that it itself is one way to interpret it, or the next number along with it is also a way to interpret it. So now that we have this way, we just let's look through, finish this. So if it's 0, so we return dp I is equal to 0, because for this string, right, there is no way to decode it, 0, 1, 2. Okay, then now we go to the last one. So 1. So it's not 0, we go to the else. So it will actually just be a combination of at 1, right, we need to check. There's two possible ways. We either do 10 and 12 as one way, or 1 and 0, 1, 2. So since 1 and 0, 1, 2 just implies that we are doing this. This line just implies 1 and 0, 1, 2, which is of course 0 ways, because dp of 0 is equal to dp of 1, which is 0. Yeah, because dp of 1 is 0 here. So if this is valid and 10 is also a valid number, right, then we will have to look at this. So 0 plus dp of 2 is equals to 2. So 0 plus equals 2 is 2. So answer is 2, which is correct. So this is the iterative method to go through the recurrence relation. So the recurrence relation actually is an index of 0, for example. You have to take into account if the first character is valid, then you go for answer the subproblem of index 1 all the way to the end. And if the first 1 and 2 characters are valid, then you go for the subproblem starting from the third index. Yeah. So the first DFS flow, right? We go from left to right, top-down approach. So 1 can be used, so we have to check 0, 1, 2. 0, 1, 2 cannot be used, so we return 0. So this implies that 1 and 0, 1, 2 is not valid. So the first character counted 0. Okay, so now we look at the second DFS flow. So we assume that the first and checking character are valid. So 10 can be used. So actually at this point, there's no point in checking. It's splitting up 0, 1, 2. Yeah, it's just 0. Because you cannot split it like that. So you have to check whether you can split it like this. So let's see. So 10 can be used, so we check 12. So this implies that 10 and the subproblem of 12 is valid. So this does not imply that this is one way to do it. It just means that it's valid subproblem. So we have to check 1. 1 can be used, so we check 2. 2, this implies that 1 and 2 are valid, a valid way of interpreting 12, the subproblem of 12. So since 2 can be used, we check the empty string and then we say that there is by default nothing else after 2. So 1 and 2 form one valid pairing. So since 12 both digits can work, right? We check the empty string again, there is nothing else after. So 12 also forms one valid combo. So from these 3 lines, you can see that the subproblem of 12 has 2 solutions, right? So 10 and the subproblem of 12, right? It's not 1 plus 2. It's because this is a valid pairing, so it's even valid. If this was not a valid pairing, like 0, 1, 2, right? You don't care about how many permutations or pairings that 12 can come up with, right? It's more of, is this even valid? If it's not valid, you don't even count it, it's 0. So since 10 is valid, then you consider 12. I think that was one of the misconceptions I had at the beginning, because I didn't know whether at this point do I add or what. So we take a look at the code. Take a look at the code. So we use a map, right? Because based on the time complexity, we are allowed to have ON space. So we use a map. So this map stores from index 2 onwards, from index I onwards. So the key will be index, and the value will be how many permutations at the index. So for instance, at index 2, for this, 2 and 3 form 2 permutations. So index I will be 2. So let's look at the code. So of course, our bounds only one way to decode. Yeah, so if you can reach here, if you can reach here. So DFS is equals to start index. Okay, so it's a inbuilt, it's a function that I put it within this object. And if s.char and character at the start index is 0, meaning for example like 0, 1, 2, you return 0 because there's no way you can decode this. Yeah. So it's just outright zero. So this takes into account any number or string that starts with zero. Then if the map has already had the start index, meaning let's say at index 2, I can return 2, right? So at index 2, at index 2, there are 2 ways. So I will just return it. This is the memoization part. Okay. So we do one round. First character counted, right? So at this point, right, if your first character is valid, meaning it's not 0, meaning it's 1 to 9. It can be all 1 to 9 is A, B, C, D, E, F, G, H. A, B, C, D, E, F, G, H, I. Yeah. So okay, so sorry about that. So at this point, if the first character is valid, we have to count it, right? So we don't already have a count for it, so we don't return it, right? So first character is counted. It means it's a new character that is counted. Okay, then we have to do DFS on the remainder. So for instance, at this point, 1 is counted, so we'll check 0, 1, 2. 0, 1, 2 doesn't count. So first character rate counted is 0 for 1 and 0, 1, 2. Okay, so now we have to look at the second character is also counted. We initialize it with 0. And we say if start plus 1 is less than s dot length, right? So we have to check that it's not the last index. So second last index, so we check the first character, is it 1? And if the first character is 2, then we have to make sure that it's less than equal to 6 because there's only 26 characters. And then we can just say second char counted is equals to the DFS of the, so for example, this is for 10 and 12. So we'll 10 and 12. So we'll call DFS here. So DFS for 12 will enter here, right? So first character counted, so DFS of 1 plus 2 plus 1, so it's 3. So at index 3, nothing. So we do DFS of 4. DFS of 4, map has, because empty string is 1, then you return upwards. So DFS of 4 is equals to 1. First character counted is 1 for 12. Okay, so 1 and 2. First character counted means that second character there's only 1 way to do it. Yeah. So second character counted from, we will count 12. Right, 1 and 2. We are now at 1 and 2. So we're now at this line. So 1 and 2, we will check the empty string. Right. So DFS of 2 plus 2 is equal to 4, and then we will return because there's a memoization. So second char counted will be 4. Will be 2, sorry, will be 1. So DFS of 4 is 1. So first char counted is 1, second char counted is 1. So we will map index of 2 with a total of 2. Yeah. So if let's say you were to log the map out, right? You were to log the map out, you will see that initially index of 4, which is end of string, is 1. Index of 3 is also 1. Because index of 3 is at this point, correct? So we do DFS of 3 plus 1 is 1. Of DFS of 4 is equals to 1. And then second char counted. This one we cannot enter the block, so 1 plus 0. We will map index of 3 to 1. Okay. Then later on we'll go in, we'll say that the index is smaller now. So what we do? Second char counted, DFS start index of 2, 4. So this is 1. So first char counted will go back, will return, the total return will come here. So index of 1 plus 1. I got a bit confused. So the next round, you'll come back here. So this is 1. Okay, so the subproblem of 1 of 12 is 1 if you count the first character. Okay, then we have to look at the second character. Second character also adds another one. So first character is one if you account one and two separately. Second character if you count 12 as a whole. So we will map index of 2 to 2 because index 2 to 3, index 2 all the way to the end is 12. So this one indicates that 12 from index 2 all the way to the end, there's two ways you can do it. Yeah, so this will return to here because 10 and 12. So first char counter is 0 for 1 and 0, 1, 2. So this is for 1, 0, 1, 2. So second char counter is 10, 10, 12. So there's two ways that we can go about doing this, 0 ways we can do about splitting this. Then we will just add it together, we get 2. So we get index 0 is equals to 2. And then we pretty much just get the answer. Okay, so this implies that if, let's say, let's use this one. I change the test case to 1000. I run. There is 0 ways because first character counted, 0 ways I can do this, so I return 0. This one counted, so it's counted and there is 0 ways I can do this, so I return 0. 0 plus 0, 0. Okay. So this one, let's take a look at the space complexity. Obviously is O(n) because at each index of the string, you will get one map count maximum. For time complexity, even though this is DFS, there is memoisation. So each index will only get processed once because the second time you are so-called looking for it, right? You don't go into a whole recursive tree. You actually just fetch from memoisation. So the sub-problems will start all the way, because it's DFS, it goes all the way to the end, to the last indexes. So you'll start from sub-problem of 2, sub-problem of 12, then subproblem of 0, 1, 2, then subproblem of the whole question. So the time complexity is also O(n). So yeah, this is the question, my submission for the day.